Hi, everybody. So today we are going to continue with our introduction to anatomy and physiology. We are going to be focusing on the concept of homeostasis, which is basically essential for keeping us alive. So what is homeostasis imply? So for us to understand this, I need you guys to first think about the fact that for your body to run smoothly, it requires a certain setup, certain characteristics, and certain numbers to be proper and within a specific range. If these numbers fluctuate away from this normal range, then it's typically going to cause what we identify as an imbalance, and in many cases, this imbalance will basically cause a disease. So our body has the capacity to maintain this environment, which is our internal environment, regardless of what is happening outside our body. And again, if this balances out, then we identify this as an imbalance, and it's usually associated with a disease. So the proper word for our ability to maintain our internal environment is homeostasis. So homeo means the same, stasis means the status. So when you're looking at these vocabulary, again, kind of go back to that root words that make the word, and that will help you understand the meaning of the word as well. So some of the main systems that are maintained through homeostasis in our body include our blood pH. Blood pH implies basically the acidity or alkalinity of your blood. And right here, the number range that we have is 7.35 to 7.45. We will go into more detail about this in our next lecture. We have concentration of ions. Ions basically refer to things like calcium, sodium, potassium, chloride, etc. So for each of these ions, you do need to keep them at a specific range. So I didn't give you any number in this case because each of these numbers or ranges will be different for each individual ion. Blood pressure is a very common one. So when you go to the doctor, one of the first things they do measure is your blood pressure. So we say on average, this number would be 120 over 80 millimeter of mercury. And again, this number might be fluctuating from somebody who's younger versus somebody who's older. But again, we're talking about an average number here. Blood glucose is another main one. Glucose is essential for our survival. It's the main source of energy for our body. Therefore, the level of glucose needs to be maintained at a specific number. And this range, again, will be slightly different regarding, depending on which textbook you use. But they usually say the range is between 90 to 100 milligram per deciliter. Milligram is a measurement of weight. Deciliter is a measurement of volume. Deci implies 1/10 of a liter. Body temperature is another one. So if you ever basically been sick, one of the first things that they check is to see if you have a fever. The typical body temperature we say is 98.6 degrees Fahrenheit, which is equivalent to 37 degrees centigrade. And then lastly, we have our heartbeat, which is ranging between 60 to 100 beats. And again, this is a really big number, but this number ranges for people who might be athletes with with a lower heart rate versus somebody that might not be the most athletic person may have a higher range within their heartbeat. Now, the question is, we're talking about all of these systems are being internally maintained. Now, the question is, what is enabling us inside our body to maintain these systems? And the answer is 2 of our 11 organ systems, and they are nervous system, which is basically going to be made up of mainly your brain and spinal cord, and endocrine system, which is responsible for production of hormones. And through those hormone production and the release of those hormones, they can control the homeostasis balance. So moving on, what is the question? The next question is, how are we using this system to actually maintain homeostasis? So first thing that I want you to understand is when we're talking about homeostasis, it is not going to be a single number that we need to maintain. It can be a range of numbers. So for instance, if you look at the numbers that I have given you earlier, for instance, for heart rate, your heart rate was 60 to 100 beats per minute. So if you fluctuate, let's say you're resting and your heartbeat is at 70 beats per minute, and then you lay down and your heartbeat goes to 55 beats per minute, that is still acceptable for your body because it says, quote unquote, you're still in green, right? You're still okay. Now, what if you fall above or below this acceptable range? So what if the fluctuation we're describing is above or below what is acceptable as normal? In such a scenario, then what we activate is what we identify as a feedback system. So feedback is activated to allow you to reestablish your homeostasis. So what is this feedback and what are the steps involved in this process? So let's take a look. So this is going to be essential for you to understand homeostasis step by step and how you can reestablish homeostasis if there is an imbalance. So we start with what we identify as a stimulus. So stimulus is basically, again, any changes that is happening that moves or fluctuates below or above what we're accepting as normal range. Kind of think about this. Let's say for your heart rate falls below 60 beats per minute or reach above 100 beats per minute. Or when we're talking about your temperature, let's say the fluctuation allows your body temperature to go above about 37 degrees centigrade or fall below about 37 degrees centigrade. Now, when this change happens, if nothing noticed that change, it's just going to continue happening, right? So what you need is for that stimulus, for that change to be noticed by something. So those fluctuations are going to be noticed by what we identify as the second part, which are your sensors. So think about the word sensor. It is sensing a change, right? So in this case, your sensors are going to be basically different parts of the body, depending on the homeostatic feedback loop. And these systems are basically checking to make sure your numbers are staying in green. And if they are fluctuating into yellow and red, then that's where they trigger the whole system to basically start working to reestablish the homeostasis feedback or to establish your homeostasis. Now here's the thing. Sensors mostly by themselves cannot accomplish a task. So they need to send a message to their boss. And I put that in quote unquote again. So the boss that is going to receive the data from the sensor are referred to as integrators. So the integrators are going to be typically your endocrine system, which we mentioned earlier, responsible for production of hormone. Or it could be your nervous system, which is going to basically communicate using electrical impulses. So what is the integrator going to do? Again, integrator is going to receive the data from your sensor, interprets that data, so makes sense of that data, and then based on what it has interpreted, it's going to create a response. So it says, based on the, let's say, increase in temperature, I need to be doing this, this, and this to return the body temperature back to normal. Now, integrator itself is not going to take those steps. Think about the integrator as your big boss, right? Your boss is not going to go do the legwork. So what it's going to do is going to send a message to where? To the next part, which is your effectors. So effectors are going to basically be your workers. These are the organs that are responsible for correcting the problem, right? Correcting the change. What they actually work on, the actual work they're accomplishing is identified as the response. And again, we identify that as the change. Now, the final thing is the result that you accomplish, which is again, returning everything back to homeostasis. So every time you think about an imbalance in terms of homeostasis, If I give you a statement, you always want to recreate this for yourself. You want to say, what is the original fluctuation? What noticed that fluctuation? What that message, where did that message get sent to? What are the workers that are going to do the job? What is the job they're accomplishing? And again, what is the final result after the job is done? So let's take a look at an example for body temperature homeostasis. So again, notice I've already written down for you the steps that are involved in our feedback loop. So let's start with the stimulus. So our stimulus in this case is going to be increase in body temperature. So again, that's typically going above 37 degrees centigrade or 98.6 degrees Fahrenheit. What is going to notice my change, which are basically your sensors, are temperature receptors, which we also call them thermoreceptors, that are found in the skin, and hypothalamus. If you haven't heard of the word hypothalamus before, this is a part found in your brain. So it is extremely important. We'll talk about this further in a nervous system, but just kind of hint at that sensors are part of the nervous system. What is your integrator? What is your, again, code, big boss, right? So your integrator in this case also going to be your hypothalamus, which is again part of your nervous system, one of the two systems that could be your integrator, either nervous system or endocrine system. So the big boss, your hypothalamus, makes a decision, says based on the changes I've noticed, what can I do to fix the problem? So it sends a message to your effectors. Again, your effectors are going to be your workers. So in this case, what are my workers? Your workers are your skin, blood vessels, and also your sweat glands. So these are the ones that are going to help you return your body temperature back to normal. So the response was the work they're going to do. So what is my skin, blood vessels, and the sweat glands are going to do? My blood vessels in the skin are going to open up. Another way, they are going to dilate, and they're going to release a significant amount of heat to the surface of the body. So again, when somebody is hot, you can see them getting flushed because they're getting rid of that extra heat by opening or dilating their blood vessels. And you're also going to have sweat glands in your skin that are going to basically allow you to sweat, and sweating is allowing you to also release heat, basically cools you down. So what is the final result? Final result would be decreasing your body temperature back to the normal or homeostasis. So that is it for our homeostatic feedback loop. Please keep an eye on this. For the exam, I do expect you guys to be able to recreate this chart or be able to identify a specific steps involved in the homeostatic feedback loop if I present you with a paragraph. So you should be able to, again, pick the specific components within your feedback loop from a statement. Thank you.